Trigonometry Unit Section 3, Solving Problems Containing No Right Triangles. Sometimes you will encounter problems where no right triangles are readily apparent. The good news is that many of these non-right triangles are isosceles or equilateral. It is usually good news because right triangles can be created from them. Then we can use the right triangle trig to solve the problem. In this first example, they're asking us to determine the height of this isosceles triangle. To do that, we will begin by drawing an altitude from the upper vertex of this isosceles triangle to the opposite side. This will create two identical right triangles. And if you recall, that altitude bisects the opposite side. We'll have our 40-degree angle. We're looking for the height, and 15 divided by 2, the bisecting of this opposite side, gives us a leg length of 7.5. We now can use 40 as a reference angle, label the sides of the triangle, pick the trig ratio that deals with opposite and adjacent, which is the tangent, replace what we know in the variables, and solve the equation. In this particular example, we will multiply both sides by 7.5 to give us a height that ends up being 6.3 feet. In this next example, they're asking us to determine the length of a side in this equilateral triangle. Again, we will draw an altitude to help us out, and it doesn't look like there's very much information other than we know the length of our altitude. But there's some hidden information here if you recall the facts of an equilateral triangle. One of them is that all the sides are the same length and all the angles are 60 degrees. So after we've drawn our altitude, we have two equal right triangles formed. The lower acute angle is going to have a measure of 60 degrees. Our height has been given, so our vertical leg has a length of 48, and if we use our 60 degrees as our reference angle, we can determine the length of the hypotenuse in this right triangle, which is equivalent to one side of this equilateral triangle in the question that's being asked. So labeling the sides, it ends up we have an opposite given, and we're looking for the hypotenuse. The trig ratio dealing with opposite and hypotenuse, OH, is sine of the opposite over the hypotenuse. In this example, the variables in the denominator, we will switch y in sine of 60 degrees. And solving for y, we will take 48 divided by sine of 60 for a final value of y, which isn't actually the length that we were looking for. Here's y, which was this length, but the good news is that that will be the same as this side as well as this side. Now in this problem, the answer was 55.4. We could have just as well solved for this side here, the adjacent, used a different trig ratio with our opposite and our adjacent, but then that would have been here halfway. We would have had to double that, but either one of these would result in the same final answer. For additional practice on these types of problems, turn to page 64 in your book.